Hey guys, today we're going to talk about converting quadratics between vertex form and standard form. Here on the screen you can see vertex form is on the left. This is where we have the parentheses h and k squared, and then on the right we have standard form, which is something that we're going to be dealing with a lot in this unit. So our goal is to get comfortable moving from one side to another, switching from one notation to another, and being able to use as much information as possible because they both tell us different things. Okay? Let's get started. Here we're going to start with converting it from standard to vertex. Okay, so what I like to do is I like to know where it is that I'm going with this problem. So I always write down my end result at the bottom. I want it to convert it in this notation. Now, this equation that we've given right now is written in standard form. So it looks like this. Okay, it's written in this form. Now, one thing that you should notice is that they both have the letter A as a variable, which means they're both going to share that value in common. Okay, here this 1/2, this A equals 1/2, it's going to go right here for A. So let's start writing out our equation. Okay, we have f of x equals A. Here, let me back it up a little bit. X minus h squared plus k. So the A is going to be 1/2. It stays the same. We know that this parabola is wide and it's pointing up because it's positive. So it shouldn't change direction or narrow or how wide it is based on changing from one form to another. Okay? Now what we're missing is the vertex. So what we're going to do here to find the vertex is we're going to go to Desmos. And I already have it graphed here on the side. We're going to go to Desmos and we're going to graph this function. By graphing it, it allows us to find the vertex on the graph. So as I move across here, I can find the vertexes down here at 8, -29. So the vertex is 8, -29. This is my h and my k. So all I really want to do with that vertex that I found on the graph is plug it in for h and k. We're going to plug these letters for h and for k. So our function comes out to f of x equals 1/2 x minus 8 squared plus -29, or just minus 29. A few things to note here as we convert from standard to vertex is paying attention to the fact that the vertex is always going to be the opposite, right? The x minus h, it'll always be opposite. So if this is a negative number, this changes to positive. If it's positive, it changes to negative. The number in the outside stays the same. And that's really it to convert from standard to vertex. Let's talk about how we convert from vertex to standard. Okay, so from vertex to standard, what we're going to be doing is we're going to be using 3 steps to do this. We're going to start with box method, and then we're going to do distributive property, and then we're going to combine like terms. Okay, this x minus 1 squared, this piece right here, x minus 1 squared, really just means x minus 1 times x minus 1. It's the same thing. So kind of like saying f of x is like saying 5 squared, right? You have 5 times 5. Or 10 squared is 10 times 10. Anything squared is being multiplied by itself. So I can just rewrite this problem as -2 x minus 1 times x minus 1. That's what it means to have x minus 1 squared. So how do I multiply these x minus 1 squared? Is we're going to do a box method. So the box method allows us to neatly organize all of our work. We create a box with 4 squares, 4 quadrants, and we write x minus 1 on the top and x minus 1 on the left. And our purpose here when we're doing box method, if you remember from Algebra 1, is to multiply the numbers on the outside or the variables on the outside and fill in the boxes on the inside. So on the first quadrant, we have x times x, which allows us to get x squared. On the second one to the right, we have x times negative 1, which gives us negative 1x. On the bottom left, we have negative 1 times x, so we fill that in with negative 1x. And then lastly, we have negative 1 times negative 1, which turns to a positive 1. So we multiply to fill in the box, and now what do we do with what's inside the box is we combine like terms. We're going to add everything together. And the only like terms when you're adding all of these up will always be the diagonal numbers. These diagonal boxes are going to be the ones that are going to be combining with each other. Okay, so we have x squared minus 2x plus 1. Those are that's what's going to end up being the result. So this right here that we got is really just this piece, and we're going to replace it with that. X minus 1 times x minus 1 is really just x squared plus 2x plus 1. So let's rewrite our problem down here and finish this off. So we have negative 2 times whatever we got, which is x squared minus 2x plus 1. Plus 3. So we're just copying down everything, and we're replacing the work that we did inside the parentheses. To finish this problem off, we're going to do distributive property. So we're going to distribute the negative 2 on the outside into the parentheses. So first we have negative 2 times x squared, which gives us negative 2x squared. Negative 2 times negative 2x gives us positive 4x. And negative 2 times positive 1 gives us negative 2. And then we just bring down the plus 3. The plus 3 is going to come down because you cannot distribute the negative 2 when it's outside the parentheses, right? You only distribute inside the parentheses, not to anything extra. So we bring down the plus 3. In our last step, we're going to combine and simplify this equation as much as possible by combining like terms. Okay, how do we combine like terms? Is you look at what we have in common, and the only things that we have in common here are these numbers in the end. So our function comes down to f of x equals negative 2x squared plus 4x plus 1. And this is our function in standard form. We start with vertex with parentheses, and we finish with no parentheses at all. Okay, there's a lot of reasons why we want to be able to get comfortable with both of these situations. Okay, we have vertex form, we have standard form, and this is the reason. When you're dealing with vertex form, we have f of x equals a x minus h squared plus k. This right here, the h and k, tells me the center of the graph. It tells me the vertex. Okay, that's why it's called vertex form. Standard form has ax squared plus bx plus c. The c value is going to be the y-intercept. So whatever you have there for c, it's where it's going to cross the y-axis. Okay, and then of course they both tell you whether the parabola is wide, narrow, if it's pointing up or if it's pointing down. The a value is the same for both, so they both tell you that information. All right, guys, I hope this helps. Please let me know if you guys have any questions. Leave me a comment here below. Smash the like button, and if you haven't subscribed, go ahead and subscribe. All right, there's a lot more videos coming this second semester that are not just pertaining to math, and I hope this helped. As always, I'll calculate later.